Now for the faculty spotlight, I'm pleased to introduce Karyn Frick, a neuroscience professor in the psychology department here at UW-Milwaukee. Dr. Frick was recruited to UWM in 2010 after a decade at Yale University. In very general terms, Dr. Frick's primary area of research focuses on hormones and age-related cognitive decline and dementia. No personal comments about me in that area at this point. An important concern given the rapidly expanding elderly population worldwide, of which I'm joining. Please join me in welcoming Dr. Karyn Frick.
Thank you very much. Thank you very much for the opportunity to describe our research. And there we go. My career has been spent trying to understand how memories are formed under both normal conditions and when memory formation doesn't go quite as we had planned, particularly during aging and in Alzheimer's disease. As I'm sure you're well aware, Alzheimer's disease is a neurodegenerative disease. It's marked by brain atrophy, which you see potentially, there we go, up here in this brain, where there's severe loss of brain matter, as well as protein inclusions in the brain we call plaques and tangles. Alzheimer's is the leading cause of dementia, marked by severe memory loss, confusion, and impaired planning, judgment, and decision-making. Eventually, the disease itself attacks the entire brain, robbing its patients of the ability to perform basic daily activities, dressing themselves, feeding themselves, etc. And unfortunately, the incidence of Alzheimer's disease is rising. So these are data from the Alzheimer's Association showing the incidence of Alzheimer's. Now it's about 5.3 million Americans over age 65. Will rise to about over 13 million by 2050. And unfortunately, there are few potential cures on the horizon. No one has ever survived a diagnosis of Alzheimer's disease. And so we desperately need new treatments for the prevention and treatment of Alzheimer's disease. If Alzheimer's has not affected your family, unfortunately it will. It's affected mine most recently with the death of my aunt here, who you see 15 years ago holding my daughter when she was born. The picture on the right is her in November, just before she passed away of Alzheimer's disease. And my aunt is typical of most Alzheimer's patients in that she's female. The incidence of Alzheimer's disease among women is considerably higher than it is among men. So as you can see here in these data from the Alzheimer's Association, this is the estimated lifetime risks of Alzheimer's disease at ages 65, 75, and 85, with men in the purple and women in the gold. And you can see that at each age, the risk for women is much higher. And we think that that's because, at least in part, because of menopause, because of the loss of hormones, estrogens and progesterone, but particularly estrogens, that happens during menopause, where hormone levels are very high before menopause, and then you can see this precipitous drop at menopause. That's important because these estrogens are important chemicals for keeping neurons in the brain alive, particularly neurons that live in parts of the brain like the hippocampus and prefrontal cortex that are necessary for cognitive function. And hormone therapy might seem like a pretty good option for replacing these hormones, and it potentially can be, but there are also side effects that you've probably heard about in the news, cancer-causing, stroke-causing side effects. So what we are trying to do here at UWM is to figure out exactly how these hormones, particularly the potent estrogen estradiol, regulates memory. We think that if we can figure out exactly the molecular mechanisms through which estradiol regulates memory in parts of the brain like the hippocampus, which is here in this figure in orange and yellow, and we can figure out how those molecules regulate memory formation, those molecules could potentially be targets for drug development, for new drugs that can help prevent and reverse Alzheimer's disease. I won't go into too much detail, just give you a brief idea of how we measure memory. We do all of our work in mouse models of aging and Alzheimer's disease. So how do we measure memory in a mouse? We can use very simple object-based tasks using objects that we can buy here on campus or in a hardware store that we put in an empty white box and allow animals to explore these objects for up to 30 seconds at a time. In this case, they're exploring 2 identical objects placed near the corners of the box. After a delay, after drug treatment and a delay, the animals are then allowed to explore an object that's identical to one they've seen before and a novel object. Because the life of a mouse in the lab is pretty boring, any new things that you present to them, they're really interested in exploring. And so here, if they remember the old object, they're going to spend more time exploring the new object. So we can tell how well the animals have learned what the objects are in this task called object recognition, and we can use a task called object placement to tell how well the animals know where the objects are in space. We simply take one of the training objects and move it to a new location in the box, here now the lower corner. Just to give you an example of what the data might look like, I promise, these are the only data I will show you. The animals can spend, as I said, 30 seconds exploring the objects. 15 seconds is chance. That means the animals have spent the same amount of time exploring the 2 objects. And in both tasks, animals receiving a control substance, what we call vehicle, spend the same amount of time with the 2 objects. But animals in which we've infused a dose of estradiol directly into the brain, into the hippocampus part of the brain, spend more time, as illustrated by, I can't even see, this higher bar here, are spending more time with the novel and the moved objects, telling us that they remember the objects during training. So we can then take these data and try to figure out what causes this memory enhancement. And I am most definitely not going to go through this model, but just to show you the kinds of things we do to try to understand the receptors in purple, the enzymes in green, the things affecting gene expression in orange that may be future targets for drug development. I want to end by just mentioning that this work is funded by extramural and intramural grants. So we currently have 2 National Institutes of Health grants to study this question. We also received an inaugural sex and gender in Alzheimer's disease grant from the Alzheimer's Association recently to study the interactions between estradiol and apolipoprotein E, which is the leading genetic cause of Alzheimer's disease, or genetic risk factor, sorry, for Alzheimer's disease. And then we also have 2 UWM Research Foundation grants that have funded the work as well. We have presented this work in published papers, in book chapters, in presentations given by myself and my students many times since I've been at UWM in the last 8 years. And finally, I just want to end by acknowledging the work, the hard work of the people in my lab. I'm the ideas person, the publicity person. These are the people who really do the work in my lab. So we have 2 postdocs in the lab right now. We have 3 graduate students with 1 more joining us in the fall. They've been supported by research assistantships from my grants, by TAs from the College of Letters and Science, as well as the graduate school fellowships as well. And then these are 5 of my 8 undergraduates who are working in the lab, many of whom have been very generously supported by the Office of Undergraduate Research. I simply couldn't do this work without them. So I thank you all for your support of the students and our funding agencies for funding. Thank you.